So let's look at what's the area of a triangle. So we'll start with right angle triangles. So if you have a right angle triangle which has a certain base and which has a certain height, what is its area? This is what we'll look at, and we can do this with pen and paper. With paper, we can fold paper and create triangles, but we'll just do it with material today. Okay, so if I take, let's say, this rectangle, right, and I cut the diagonal at a diagonal, like we do for lunchbox. When you have sandwich, you will cut at a diagonal so that you get to eat the center and not the corners first, something like that. So you cut it. So it's like a sandwich. So when you cut it like a sandwich, you expect that both the sides of the sandwich will be the same. Of course, if you fold it on top of each other, you will not find that. So even in paper, when you fold it on top of each other like this, it will not match. So you have to pick it up and put it like this. Then you can see that they are the same. So the area of this square, in this specific case, base is 2 and height is 1, 2, 3, 4, 5. So the area is 10. These 10 squares, half of it is there in this triangle and half of it is there in the other triangle, because two of these triangles fit perfectly and they make an area of 10. So you take another rectangle. So in this case, the base is 4 and the height is 1, 2, 3, 4, 5, 6, 7, 8. 8. Yeah. So 8 times 4, 32. So the area of this rectangle is 32. This can also be cut as a right angle triangle, and the other right angle triangle will fit on top of it. Yeah? So when you do it in paper and children try to fold the paper and see that it's the same, it won't be the same. Only for a square, these two will land on top of each other. Otherwise, it will always look like mountains. So you have to cut it out and put it on top of each other for it to work. So this is the second example. Let's take a few more examples. Here's one more. So in this case is 1, 2, 3, 4. This is also 1, 2, 3, 4. So this is actually a square. So in this case, you'll be able to just fold it on top. No. 1, 2, 3, 4, 5. This is 5. Okay, so then you cannot fold it on top of each other. And so again, you need to match the 4 with 4 and 5 with 5, and then you say this is half. So for any of these, even a tiny one like this one, right, you are going to have two triangles in a rectangle. So the way you get the area of it's supposed to be a right angle triangle, but anyway, that's just a little better, is that any rectangle that it fits under, yeah, it will be half of that rectangle. The area of the rectangle is base into height, we know that. So the area of the triangle is half into base into height. For a right angle triangle, it's clear. Okay? So again, this can be drawn, but let's say you have a triangle that's not a right angle triangle. Then you can draw basically an altitude, and you can make it into two triangles. In this case, it turned out to be an equilateral triangle, but even if the triangle was not equilateral, you will be able to make two right angle triangles out of it. So for half the right angle triangle, you know the area is half base into height. This is also half base into height. So obviously the area of the whole triangle is also half base into height. So this is the way to prove that area of a triangle, even if it is not right angle triangle. Let's say I'll draw it a little more obviously, that it's not even an equilateral triangle. Then it can still be split into two right angle triangles, and each of the right angle triangles can have their rectangles, and the height is the same and the base together is the same. So the area of the full rectangle is base into height, where this is the total base, right? And the area of the triangle is still half base into height, with this triangle fitting with this triangle and this triangle fitting with equal to that triangle. So this is also half base into height. So in the example we were taking, there would be a piece that will complete this one, and there will be a piece that will complete this one. That's what we are saying. So it will still be, there's that full rectangle, it will still be half of that rectangle. Alright, so I found a couple of triangles we could mix to get this. So in this case, as we said, this will be half of that and this will be half of that. So you will still be able to find a rectangle. If the base is the same and you can find a rectangle to enclose it, then the area of the triangle is half of that rectangle. That's the idea. Okay, so in the next part we will find a way of looking at, if they are all acute angles. If you have an obtuse angle, then what are we talking about?